Welcome back to the second part of our lesson on the general form of a linear equation. Remember, the general form of a linear equation, sometimes referred to as the standard form, is the form ax plus by equals c, so we have the x and y terms on the left and the constant on the right. Here we're given the linear equation in general form 3x plus 2y equals 16. We're asked to write the equation in slope-intercept form, give the slope, give the intercepts, find additional points on the line, and graph the line. To write the equation in slope-intercept form, we want to solve the equation for y. So beginning with 3x plus 2y equals 16, we first want to isolate the y term, so we'll subtract 3x on both sides. And now we'll simplify. So we have 2y equals, now on the right side we have a choice here. We can write this as 16 minus 3x, but in slope-intercept form, we normally have the x term first and the constant second. So let's write this as negative 3x plus 16. And now for the last step, we would divide both sides by positive 2. When dividing the right side by 2, we'll divide each term by 2. And now simplifying, we have y equals, here the coefficient of x is negative 3 halves, so we have negative 3 halves x, and 16 divided by 2 equals 8, so we have plus 8. So this would be the more common form for the equation in slope-intercept form, but if we wrote this difference as 16 minus 3x instead of negative 3x plus 16, our equation would be in the form of y equals, we'd have 8 minus 3 halves x. Both of these are okay for slope-intercept form, but this form here would be more common. So I'm going to go ahead and give the linear equation in the form y equals negative 3 halves x plus 8. And now that we have the equation in slope-intercept form, notice how the slope m is equal to negative 3 halves, and the vertical intercept b, or y-intercept, is equal to positive 8. So the slope is equal to negative 3 halves, and the vertical intercept, or y-intercept, which we should give as an ordered pair, would be 0, 8. Next, we're asked to determine the horizontal intercept. There's no shortcuts here. We'll have to set y equal to 0 and solve for x. So what I want to do now is determine both the vertical and horizontal intercepts using the general form of the equation, just to show that we can find the vertical intercept more than one way. So beginning with the given equation 3x plus 2y equals 16, we'll find the vertical intercept again, but this time we'll set x equal to 0 and solve for y. So that would give us 3 times 0 plus 2y equals 16. Simplifying, 3 times 0 is 0. Whenever determining the vertical intercept using the general form of our equation, the x term will always simplify out because we're substituting 0 for x. So this gives us the equation 2y equals 16, dividing both sides by 2. We have y equals 8, which means the vertical intercept is 8. As an ordered pair, we would have 0, 8, which we actually already knew. And now we'll find the horizontal intercept. So now we'll set y equal to 0 and solve for x. So we'd have the equation 3x plus 2 times 0 equals 16. 2 times 0 is 0, so we have 3x equals 16. Notice how when determining the horizontal intercept, the y term always simplifies out because we're substituting 0 for y. So dividing both sides by 3, notice how we have x equals 16 thirds. 16 thirds is a mixed number, would be 5 1/3. So the horizontal intercept would be the ordered pair 16 thirds, 0, or 5 1/3, 0. So going back to our previous slide, again, we already know the vertical intercept is 0, 8, and we just found that the horizontal intercept is 16 thirds, 0, or if we want, 5 1/3, 0. Here we're asked to determine additional points on the line, but we'll do this after we graph our line. So to graph the line, we'll use a point and the slope. So let's use the vertical intercept as our point. So we'll plot the point 0, 8, which is here, on the vertical axis. And now the slope is negative 3 halves. So if the slope is negative 3 halves, let's write this as negative 3 over positive 2. So because the numerator is negative 3, we would go down 3 units. And because the denominator is positive 2, we would go right 2 units from the given point to determine additional points on our line. And we'll do this multiple times to find several points on our line. Whenever graphing a line by hand, the more points we find, the easier it is to make an accurate graph. So from the vertical intercept, again, we'll go down 3 units and right 2 units. This point would have the ordered pair 2, 5. We'll do that again, down 3, right 2. Here we'd have the ordered pair 4, 2. Going down 3 and right 2 again, we would be here at the ordered pair 6, negative 1. And let's go ahead and do that again. Down 3, right 2. Here we're at the ordered pair 8, negative 4. Let's go ahead and graph our line. And now for our additional points, we can select any of these points on our line, but let's not use the vertical intercept given above. So let's go ahead and list 2, 5, as well as 4, 2. And let's go ahead and list one more. How about 6, negative 1? Before we go, let's talk about the slope again. Notice here we viewed the slope as negative 3 divided by positive 2. We could have also written this as positive 3 divided by negative 2. In this form, the slope would tell us to go up 3 units and then left 2 units to find additional points. So notice if we try to do this from a vertical intercept, if we go up 3 and left 2, we'd be off the coordinate plane. So in this case, interpreting the slope this way wouldn't work out so well. It was better that we interpreted it as negative 3 over positive 2. Okay, I hope you found this helpful.